Intermediate SQL. In this chapter, we will move to the next level and learn some intermediate SQL topics. More use of the where clause. Min and max. Count, AVG and sum. More use of the where clause. We have used where in the previous chapter in a very limited sense. Conditions can be much more complex than that. We have used conditions on only one value at a time so far. Why don't we try to run a query that compares more than just one value? Make sure to select the database before you start. Run the following code segment. Greater than select name, salary from employee. Greater than where salary greater than 60,000 and department underscore name equals marketing. In the example above, we are trying to find every employee in the marketing department who earns more than 60K. The conditions are separated by the and keyword. The and keyword tells us that both conditions must be fulfilled. Essentially that both values must be true. In computer logic, conditions evaluate to a true or false value. Using and we specify that both conditions on either side must be true. That means if someone has a salary higher than 60K and is from a different department, their name will not be displayed. On the other hand, if someone is from marketing and earns less than 60K, they will also not be selected. We can use and to set two conditions for the same attribute. Greater than select name, salary from employee. Greater than where salary greater than 60,000 and salary. Notice that the upper limit. This means that we will include 70,000 as a possible value. We can use other operators as well, such as greater than equals. If we used that on the above query, we would get no new values unfortunately, as there is no employee that earns exactly 60K. However, keep in mind that in a database, records are constantly updated. Thus queries can give many different results depending on when they were run. Database upkeep and maintenance is very important for this reason. We can manage this quite easily using pre-written queries and writing rules for different kinds of users. We control these using triggers, a topic that might be beyond the scope of this course. The main takeaway is that every day the database could look vastly different. For some mainstream websites, data is collected and processed every second. Think of Google. People are always using Google, even for mundane things. With Google, there is a lot of keyword analysis and user preference is always kept in mind. Thus, every time a user searches something, the database has to change or a new entry has to be added. Now let us try to find the person with the highest salary in the company. How can we do this? We will give some suggestions, however you are equipped with the tools to solve this issue. Remember that we do not need to find only the person who earns the highest salary. Thus we can run a query and sort the salary column in descending order. The first name on the list will be who we want. Run this query to find the highest salary, greater than select asterisk from employee. Greater than order by salary DESC. After running this query, we will have a table that displays all the employees sorted in descending order of salary. We will also see that there are two people with the highest salary. Now what if we only wanted to find the highest salary? Then we could simply use max. Min and max. Queries can be made extremely simple. Say we wanted to find the highest salary and only that. We could do that using the max function. The max function will find the highest numerical value for an attribute. To do so, we wrap the column inside the max function. Try running the following query. Greater than select max, salary, from employee. You will see a table that displays only one value. The value is the maximum value from the salary column. We can see that the column is named max salary. We should probably make the name a bit more descriptive. Greater than select max salary as highest salary from employee. We have used this before to change the name of the columns that are displayed. When running queries, the default column names will be the ones after the select keyword. By using an alias, we can rename the column to make more sense. We use as and put the new name in double quotes. We can also find the lowest salary by using min. Greater than select min salary as lowest salary from employee. Run the query and see what the lowest salary is. One thing that numerical domain types allow us to do is perform arithmetic on the values. Take for example, we wanted to shift to weekly pay from monthly pay. Meaning the current salary being displayed is the monthly salary. To find the equivalent weekly pay, we could divide the monthly salary by 30 and multiply by 7. This will give us the weekly salary. We assume that there are 30 days in a month. We multiply by 7 as there are 7 days a week. Greater than select name, 7 asterisk salary 30 as weekly salary from employee. Running this query will give us the weekly salary of an employee. We can use the same method to find the yearly salary of an employee. Simply multiply by 12. Greater than select name, salary asterisk 12 as yearly salary from employee. Make sure to give the computed column a name, otherwise the column will be displayed as the formula we used, like salary asterisk 12. Aliases are important as while we may know what the computation was used for, others coming across the query outputs may be confused. We use aliases to describe the role of the column. If we wanted to be more precise when calculating the weekly salary, using the yearly salary would definitely help. Greater than select name, salary asterisk 12, 52 as weekly salary from employee. Instead of assuming 30-day months, we can find the weekly salary and divide it by the number of weeks in a year. This is much more accurate as the number of weeks in a year will not change unlike the number of days in a month. This is a lesson in being observant. With some critical thinking and analysis, you can make the results of your queries much more precise. You can also make your queries much simpler. Another way to calculate the weekly salary would be to divide the yearly salary by the number of days in a year. Then we can multiply the value with the number of days in a week. The number of days in a year and week are unchanging values as well. But you can see how that would only make the query even more complicated. It's also more efficient if your code is simpler and easier to read. Count, AVG and sum. We can perform some mathematical calculations using functions that are already available to us. These arithmetic functions are used the same way as the min and max functions. We simply wrap the column in the brackets. Let's try to find the number of employees in the software department. Greater than select count, name, as employees in the software department, from employee greater than where department underscore name equals, software. Using the query above we find the count of names in our table. By using the where clause we can narrow down the count to the names that work in the software department. Keep in mind we are using name for this to keep things simple. We should rather use ID or some other unique identifier. This does not matter here, so we will continue to count names. Now let us find the average salary of everyone in the marketing department. Greater than select AVG, salary, as average salary from employee greater than where department underscore name equals, marketing. Note that we can use clauses with our functions to narrow down the list of values to choose from. Finally, let's wrap this up. We need to adjust the budget of the company. All other department salaries have been adjusted but the marketing department. We need to find out how much money is currently allocated there. Greater than select sum, salary, as accounting salary total, from employee greater than where department _name equals, accounting. With this we have finished this chapter. We will learn about some other clauses in the next chapter. Try to think about some scenarios and run queries for them using what we learned here.